Hello viewers, I am Kausalya. Today we are going to solve problem number 9 under the topic Nyquist plot. Before that, it will be better if you go through the procedure of how to solve a problem using Nyquist plot. I will give the link in the description. The problem is the open loop transfer function of a unity negative feedback system is given by this expression. Using Nyquist criterion, find the value of k for the closed loop system is stable. So here the open loop transfer function is given. With this open loop transfer function, we have to tell whether the closed loop system is stable or not by using the Nyquist criterion. So the first step is finding poles, right? And finally, we have to conclude whether the poles are located on the right half of S-plane or on the left half. So here the denominator terms are known as poles and the numerator terms are known as zeros. Okay, k is a constant. It is just a number. So here poles we are having 3 poles, right? You see S and here S square. So totally we will be having 3 poles. So now we are going to find the values of poles. So here we are having an individual S. So the value of S is 0. And here we are having a quadratic equation. We have to solve this quadratic equation and we have to find the roots. So S square plus 2S plus 2 is equal to 0. So here we are using the basic max formula. Minus b plus or minus root of b square minus 4ac by 2a. So from this expression, what is the value of a? That is coefficient of s square is 1, right? So a is 1, b is 2 and c is 2 again. Now substitute these values here. So once you substitute and once you solve, you see finally we are getting the answer as minus 1 plus or minus j. Right. So these are the two roots. Minus 1 plus j is one root, minus 1 minus j is the another root. Now we are going to locate these roots on the S-plane. So again, this is our S-plane, right? This is your real axis and this is your imaginary axis and this is negative real axis and negative imaginary axis. So the values of poles are first one is s equal to 0, right? S equal to 0. So here we are locating that S equal to 0. And next is minus 1 plus j. So here is minus 1 and here is plus j. So here I am having a root. And again minus 1 minus j. So this is minus 1 and downwards it is negative minus j. So here I am locating another root. So now tell me whether we are having any roots on the right side of the S-plane. This is the right side of S-plane and this is your left side, right? No poles are lying on the right hand side. So just write it as number of poles lying on the right half of the S-plane is 0. The second step is finding number of encirclements. So n is given by p minus z. Just now we had seen number of poles lying on the right hand side of S-plane is 0, right? Here 0. And what about zeros here? So from the problem we are having a 0. So this is our problem and here we are having a 0, right? The value is s plus 3. So when you solve this, what happens? The value of s is, that is s plus 3 is equal to 0 and the value of s will be equal to minus 3, right? So again this minus 3 will be lying on the left hand side of the S-plane, right? So 0 is lying on the right hand side of S-plane is again 0. So the number of encirclement should be 0. This means that the Nyquist plot should not encircle this point minus 1 plus 0j point, right? And step 3 we are going to draw a rough Nyquist plot. So again when you look back at the problem, so this is our given problem, right? We are having a pole at origin, right? So that origin should not be covered by our Nyquist plot. Okay, you have to draw a rough Nyquist plot in such a way. So you see here origin is not covered here. So we have drawn a rough Nyquist plot. This is the basic plot for any type of problem, right? If you have poles at origin, this area should not be covered. If you don't have poles at origin, you can draw a straight line. That's it. Now we are going to divide this into different sections. So this is your section 1, this is your section 2, this is your section 3, and this is your section 4, right? And the limits are plus j infinity and here minus j infinity, right? Now we are moving to step 4, writing expressions for magnitude and phase angle. So here the first thing is you have to replace s by j omega. So here this is what I had done. So here in this case, again we are solving. See, you see j square is nothing but minus, right? So here this can become minus omega square and the remaining terms as such. And now we are combining the real and imaginary terms. So here the real terms are minus omega square and 2. So 2 minus omega square and here this imaginary term. Now we are going to write expression for magnitude. So how to write the expression for magnitude? You see, you have to square the elements as well as you have to take square root. Okay, both should be done together. So square root of omega square plus 3 square is 9. Similarly, for this omega, you have to square this omega and you have to take square root. So this square root and square will cancel each other and finally we will be having omega. Right. And here also these terms are squared as well as square root is taken. Next, we are going to write expression for phase angle. So for writing this, just we have to consider this part, right? Consider this region. So now, numerator we are having a term, right? So write tan inverse of imaginary coefficient is omega and the real term is 3. So here I had written tan inverse of omega by 3. And here omega in the denominator contributes 90 degree, right? And I am moving this omega to the numerator part, so a minus is included. And again, when you look back at this expression, again this is a denominator term. I am going to move this to the numerator part. So again a minus is here. And tan inverse of imaginary coefficient is 2 omega and the real term coefficient is 2 minus omega square. So here we have finally come up with an expression. Now we are going to analyze section wise. So first is section 1. So when you look at rough Nyquist plot, so what is the starting point of section 1? It starts at plus j infinity, right? And here it ends at plus 0, okay, plus j 0 here. So it starts at omega as infinity and ends at omega is 0. Now we have to substitute these two values in magnitude and phase expressions and finally we have to come up with this type of answers. So first keep it in mind, we are going to substitute omega as infinity. So now when you substitute omega as infinity, okay, consider this expression. Omega as infinity is anything divided by infinity is 0. So the magnitude is 0. Again substitute the value of omega as infinity here. So what happens? This becomes tan inverse of infinity. So tan inverse of infinity is 90 degrees. Right. And here this minus 90 degree, write it. And here tan inverse of 2 omega by 2 minus omega square. Okay, anyhow I am having an omega square. So this contributes an angle of 180 degrees. Right. So this plus 90 minus 90 cancels each other and finally the angle is minus 180 degrees. Magnitude is infinity and angle is minus 180. Magnitude is 0. Okay, omega is infinity, magnitude is 0 and the phase angle is minus 180 degrees. Right. Now we are going to substitute the value of omega as 0. Here when you substitute the value of omega as 0, anything divided by 0 is infinity, right? That is infinity. And now we are going to substitute the value of omega as 0. When you substitute omega as 0, this term becomes 0 and here this 90 degree comes here and finally this term also reduces to 0. So 0 minus 90 degrees again minus 90 degrees, right? So the value is infinity at an angle of minus 90 degrees. So here finally we have to find at what direction we have to rotate and what is the angle to be rotated. So minus 90 minus 180 degree gives plus 90 degree. Plus indicates we have to rotate in anti-clockwise direction. Right. Now we are going to analyze section number 2 and here again. So this is our section number 2, right? It starts at plus j0 and it ends at minus j0. When you substitute 0 here, what happens? Either it is plus 0 or minus 0. Anything divided by 0 is infinity. So magnitude is infinity. And when you substitute 0 first plus 0 here, the answer is minus 90 degrees. And right now, because just now we have seen, when you substitute 0 degrees, here this term reduces to 0, this term reduces to 0, finally minus 90. And again, when you substitute minus 0, here we have to introduce another minus sign. So minus of minus 90 will give you plus 90 degrees, right? So here, for when you substitute omega as 0, magnitude is infinity and angle is minus 90. When you substitute minus 0, again the magnitude is infinity but the angle is plus 90 degrees. Here we have to introduce another minus sign. That's it. So when you calculate plus 90 minus of minus 90 gives plus 180 degree. So we have to rotate 180 degree in anti-clockwise direction. Right. And now we are moving to section 3. So section 3 is nothing but it is a mirror image of section 1. Right. It is very clear from the diagram. You see, this is your section 1, right? And this is your section 3. So, it is nothing but both are mirror images of each other. So, it is a mirror image of section 1, right? And for section 4, analysis is not needed. Now, we are going to step 5, that is rationalizing. So, rationalizing is nothing but here we have to introduce a negative sign. That is simply we can say that we are going to take complex conjugate. Okay, in mathematical terms we can say like that. So here you see we are having j omega. So here I am having minus j omega, and here I am having, you see, 2 minus omega square plus j2 omega, but here in the place of plus I have replaced minus. So and I have multiplied and divided by the same term here, right? So the next thing is I had combined all the numerator terms together, and again I have simplified the denominator terms here, right? So this is a plus b this is of the form a plus b, and here a minus b. So what is the formula? It is nothing but a square minus b square. So here a square is 2 minus omega, a is 2 minus omega square. So 2 minus omega square whole square, and b square is j2 omega. So j2 omega whole square gives you minus 4 omega square, and here I am having another minus, so that becomes plus here, right? And here in the numerator terms just we had did multiplication, that's it. First I have multiplied this 3 plus j omega with this minus j omega. Okay, first these two terms are multiplied, so I am having an answer like this. And the next thing I am multiplying this term with this term. Okay, this is little bit bigger. So here I had multiplied the terms. So after that we had combined the terms together. So I am having only 1 omega power 4. So minus omega power 4 is written. And next thing is omega square. I am having 2 omega square terms, right? So I had combined these two. Minus 6 plus 2 will give you minus 4, right? And remaining the imaginary terms, that is terms with j coefficients, are combined together here, right? Again we are having, you see, omega cube terms I am having 2. So 3 omega cube minus 2 omega cube gives you 1 omega cube, right? And similarly here I am having only 1 omega term here, so I had written minus j 6 omega. And the next step is here, now we are going to separate the real and imaginary terms. So when you look at these two terms, you see we can take omega square commonly outside, right? So here I had taken omega square. When you take omega square, the remaining terms will be minus omega square, right? You see, minus omega square and this minus 4. And here I had taken simply j outside, so omega cube minus 6 omega. Now the next step is we have to equate the imaginary terms to 0. So here the imaginary term is, this is our imaginary term, right? So I am equating that part to 0. So when you move this denominator term to the right hand side, 0 multiplied by this term will again 0. So here I had written that, and omega cube minus 6 omega is 0. Now I am moving this minus 6 omega to the right hand side. Now these two omegas cancel each other, and finally the value of omega square is 6, and omega is nothing but square root of 6, right? Now we are going to substitute this omega square value in real terms. So what is the real term here? Here this part, right? This term, and here divided by this denominator term forms the real part. So now here I have substituted the value of omega square as 6 in this expression. So when you substitute and when you solve, finally the value of Q is found to be minus 0.25 K. Now we are going to draw the original Nyquist plot, and here this is your respective x-axis and y-axis, right? So this is our 0 degree. When you move clockwise, the angles are negative. You see, minus 90, minus 180, and here minus 270 degrees. Now we are going to draw the plot. So this is our section 1 part. So it starts at 0 minus 180 degrees and ends at infinity minus 90. So first we start with this one, and that is 0, right, minus 180 degree. So this is my plus 180 degree line as well as minus 180 degree line. So it starts at 0 minus 180 degrees and it has to be rotated 90 degrees in anti-clockwise direction. So you see it is rotated in anti-clockwise direction, right, for 90 degrees. Where it is getting ended, it ends at infinity minus 90 degree, right? So here is our minus 90 degree line. So it ends somewhere around here, right? So section 1 is over here. And the next thing is section 2. You see it starts at infinity minus 90. So this is my minus 90 degree line and this is somewhere around here infinity. It has to be rotated 180 degrees in anti-clockwise direction. So it starts here. It is rotated, you see 180 degrees it is rotated and it ends at plus 90 degree at infinity. Right. Now section 1 and section 2 are drawn and we know that section 3 is nothing but mirror image of section 1. Right. So this is our section 1. So here we have drawn the mirror image like this. Okay. This is the mirror image of section 1 here. So this is section 1. So for section 3, it is nothing but mirror image of section 1. Right. And here this intersecting point value Q is found as minus 0.25 K. Right? Yes. Okay, here arises a doubt, right? You see, here we have to cover only one quadrant, right? For plus 90 degree, it should ended over here somewhere. But why we have extended like this? The first reason is, you see, it ends at infinity minus 90 degrees, right? So anyhow, it will ending over here. So we have to cross this line and come over here. The second most important reason is we are having an intersection point. That is, we are having a value of Q over here. So whenever a Q is present, it is mandatory that our Nyquist plot should always intersect this negative real axis. Or else you can simply start here, you can end over here. And for this mirror image, you can just simply draw like this and you can finish it off. Right. The reason is we are having an intersecting point. So our plot should always, anyway, it should intersect the negative real axis. That is the first most important point. And the second thing is, from these values, our plot should end at minus 90 degree line and the magnitude is infinity. So that is the reason we are drawing the plot like this. Right. And now we are going to find the range of K. So the value of Q is said to be minus 0.25 K. So again, we all know, right? So what is the rule for stability? Here our Nyquist plot should not cover minus 1 plus 0 j point, right? That is, minus 1 point should be lying somewhere outside the plot. That is over here. Okay, not within this area. So here you see the value of Q is minus 0.25 K. Right. So this value of 0.25 K should be less than minus 1. Okay, am I making clear? Because for stability, this minus 1 should be lying outside the plot. Okay, it should be lying over somewhere here. That is outside the plot. So what about the value of this Q? This Q value should be less than minus 1. Right. I am telling the same concept in two different ways. That's the thing. Minus 1 should lie outside is same. such that the value of this 0.25k should be less than minus 1. That is, here this point value should be less than minus 1. Do you accept? I am telling minus 1 should be lying outside, or the value of this 0.25k should be less than minus 1. Both means the same, right? So just I have substituted the values, and when you finally solve, the value of k is found to be less than 4, right? So the system will remain stable when the value of k is less than 4, right? So here comes the end of the problem. If you have any doubt, let me know in the comment section. Thank you.